So now as the CAT exam has coming up close, let us revise some important formulas for quant in this video. So we'll go topic by topic and look at some of the important formulas that you should remember for getting a good score in quant. So let's start with quadratic equations. So a quadratic equation is an equation in the form ax squared plus bx plus c equals to 0. So for a quadratic equation in this form, there are some formulas that you have to remember. First of all, the root of a quadratic equation is the value of x at which this equation becomes true. So the value at which ax squared plus bx plus c is equal to 0 is called the root of this quadratic equation. So every quadratic equation has two roots. It can also have a single root, in which case we call that both the roots to be identical. But generally we have both the roots as alpha. We call the first root alpha equals to minus b plus root over b square minus 4ac upon 2a. And the second root beta is equal to minus b minus root over b square minus 4ac upon 2a. So this is the formula for finding both the roots. So let's say you're dealing with a question where you want to get some sort of equations regarding the roots and not actually find the roots themselves, or maybe find the sum of the roots or the product of the roots. In that case, you can directly use the formula which we have as the sum of the roots, that is alpha plus beta, is minus b by a, and the product of the roots alpha beta is c by a. So let's say if you had a question where there was also one more parameter over here, let's say b was lambda and all the other values were given, and you actually had to find lambda and not x, you can use these equations to get two equations in x and lambda, and then you can find lambda as well. Apart from this, there are also formulas regarding the optimization of the quadratic equation. So let's say we have the equation ax squared plus bx plus c, and we want to find what the max value of this equation is or what the min value of this equation is, and that depends on the value of a. So let's say if a is greater than 0, then we have the minimum value of this equation at x equals to minus b upon 2a, and if a is less than 0, we have the maximum value of this equation, so max at the same location, minus b upon 2a. And so the maximum and the minimum values are when x is equal to minus b upon 2a, and the maximum or the minimum value that the equation can have is minus d upon 4a, and d is the discriminant. So discriminant is nothing but, so d is equal to b square minus 4ac. So this part over here, this is actually the discriminant, the d. So this also helps us identify whether the roots of the equation are real or not. So if this is greater than 0, we have real and distinct unique roots for the equation. If this is equal to 0, we have real and duplicate roots, and if this is less than 0, then we have imaginary roots for a quadratic equation. Let's move this a little below actually, as there is some more stuff left. So apart from this, let's also just revise the basic formulas for getting these quadratic equations using factorizations. So some formulas regarding the whole squares of a plus b. So if we have a plus b and we have the whole square of that, that gives us a square plus 2ab plus b squared. So I'll just quickly write all these formulas and then we can go through them. Okay, so these are some identities that you should remember to be able to solve a lot of questions regarding the quadratic equations. So we have a plus b whole squared equals a squared plus 2ab plus b square. A minus b whole squared is a square minus 2ab plus b square. So just this sign changes to minus. A plus b whole cubed is a square plus b square plus 3a square b plus 3ab squared. So to remember this, you have the whole square. So both of these squared, you have this whole thing cubed. So you have a cubed plus b cubed. And then you have, since we are cubing it, we have 3. Here we were squaring it. So we had 2. And then there is a square and there is a b square. And when you have the same identity for minus b, you just shift the signs of the b cube and the a square part. So you have a cube minus b cube minus 3a square b plus 3ab squared. And finally, a plus b into a minus b is just a square minus b square. So these are the identities that you have to remember to be able to solve questions regarding quadratic equations. So we aren't going to solve any questions right now, but let's only go through a lot of the formulas that you have to remember. So now coming to formulas regarding arithmetic and geometric progressions. So an arithmetic progression is nothing but a series which has a constant difference between each of its terms. So let's say we have 1, 5, 9, 13, dot, 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 dot. So this is the arithmetic progression since each term has a difference of plus 4. So we are adding 4 each of the time and we start at the 1. So 1 is the first term and then this is arithmetic progression. So we just keep on adding a constant difference that we call d. So this plus 4 is the d. So let's first move these down a little bit. So yeah, there we get some more space. So in an arithmetic progression, so first let's talk about AP, then we'll talk about GP over here. So in arithmetic progression, the nth term can be found out by the formula is first term plus n minus 1 times the common difference. So the first term would just be a, the second term would be a plus d, then a plus 2d, etc. and so on. So this is how you find the nth term. And to find the sum of n terms, so let's say you want to find the sum of the first 4 terms of this arithmetic progression. So the formula for that is, so sum of n terms is nothing but n by 2 into 2a plus n minus 1 into d. So using this formula, you can find the sum of the first n terms. So for example, in this, if we wanted to find the first sum of the first 4 terms, let's say, just for an example, so this would have been 4 by 2, which is 2. 2 times the first term is just 1, so we'll have 1 plus n minus 1d. So n is 4, so 3 times d, the d is 4, so 12. So we have 13 into 2, which is 26. And you can also verify that if you add all of this, you'll get 26 as 13 plus 9. Just a small correction. So 2 times 1 would be 2. So this would be 14. So 14 times 2 would be 28. Let's just write it properly. So it's 28. And if you check this as well, you have 1 plus 4, 6. And this would add up to 22. And 22 plus 2 is 28. So it matches up. So yeah, this is the formula for the sum of the first n terms of arithmetic progression. One more formula to remember is the sum of first n natural numbers is n into n plus 1 by 2. So you can get to this formula by substituting a equals to 1 and d equals to 1, since natural numbers are arithmetic progression with a common difference of 1. Much easier if you just remember this shortcut formula. Now coming to the geometric progressions. A geometric progression is nothing but a series which has a common ratio instead of a common difference. So the nth term in the geometric progression is nothing but a into r raised to n minus 1. So let's say the common ratio is 2. So if we have a geometric progression 2, 4, 6, not 6, 2, 4, 8, 16, 32. So in this, the common ratio is 2 and here the starting term is 2. So these are the progressions which have a common ratio instead of a common difference. And to find the sum of the first n terms for a geometric progression, it depends on whether the common ratio is less than 1 or greater than 1. So if let's say r is less than 1, the sum of first n terms would be a into 1 minus r raised to n upon 1 minus r. And if r is greater than 1, we'll have a into r raised to n minus 1 upon r minus 1. So this is the formula for finding the sum of the first n terms. So n is the how many terms you're finding the sum for of a geometric progression. And there is also a special case which also appears in CAT is the sum of an infinite geometric progression. So the sum of an infinite geometric progression is given by a upon 1 minus r. But in this case, it only can be found out if r is between minus 1 and 1. If r is greater than 1, then obviously the sum is just infinity, as in this case you can see if you just keep on adding all these terms, it will not converge, it will just keep on getting bigger and bigger. So the sum of an infinite number of geometric progressions with a ratio greater than 1 would always be infinity. So this can only be found out if the geometric progression is converging to a single value, and the sum is this if the common ratio is between minus 1 and 1. So now coming to permutations and combinations. So for permutations and combinations, there aren't much formulas to remember, just some short formulas that let's just go through quickly. So if you have, let us say, n objects, the number of ways to arrange these n objects is nothing but n factorial. So let's say if you have apple, a square, a rectangle, and a triangle. So the different number of ways you can arrange this, like triangle, circle, rectangle, triangle, circle, etc., 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 is nothing but n factorial. But let's say if you have a square, a triangle, and a circle, and you have to choose two items from these three items. So you can choose a square and a circle, you can choose a triangle and a circle, etc., etc. But choosing a circle and a square is also a same thing, because when choosing two objects, we're not concerned about what the arrangement of the objects is, but just what objects are chosen. To write that mathematically, we write that as 2 choose 3. So we are choosing two objects from a total of three objects, and the formula for this is, so a general formula for r choose k is nothing but k factorial upon k minus r factorial, so k minus r factorial into r factorial. So this is the formula for r choose k. This can also be written as this, r choose k. So this is also another way to write choose. And there is also a method called stars and bars, which is nothing but a theorem to tell you the number of ways to divide some amount of objects into some amount of subgroups. So let us say we have k objects. So we have four objects. Let's assume we have four balls and we have three boxes. So let's what in how many ways can we put these balls into these objects? So we can have 0 over here, 4 over here, 0 over here. We can have 1, 3, and 0, and so on and on and on. But how many distinct combinations like this can we make? So for that, the formula is, so if we have k objects and we want to divide that into s subgroups, so the formula is k plus s minus 1 choose k. And just a little correction, this is actually the formula for K choose R. So the bigger number you write at the top. So from K objects, we are choosing R objects. So this formula that over here, K factorial upon K minus R factorial into R factorial, can be written as K choose R and not R choose K. So a small correction over here. And this is the stars and bars method. So this is the formula for what? When we want to divide K objects into S groups. So in this example, we wanted to divide 4 objects into 3 separate groups. So the formula for this would have been 4 plus 3 minus 1. So that would be 6. Choose 4. So this gives us the total possible ways to divide 4 objects into 3 groups. So these are the main formulas that you might be needing for permutations and combinations. Let's move on ahead. Now let's move to simple and compound interest. So this just has two simple formulas, but many people can make a mistake in the compound interest formula. So these are very simple formulas, but just remember them. So the simple interest formula is the amount. Amount is nothing but the amount that you will have after you have gotten the interest. You have withdrawn your amount from the bank and you have gotten the interest, or if you took a loan, amount is the amount that you have to pay back. So this is the original principal plus principal into the time period into the rate of interest. And the rate of interest over here is in decimal and not in percentage. If this is in percentage, then you have to divide this by 100. So P plus PTR. So rate of interest into principal into time period. So this is the formula for simple interest is pretty simple. And for compound interest, so this was for simple interest. Now for compound interest, the formula is amount equals to P into 1 plus R by N raised to NT. So over here again, R is in decimal and N is the number of times the interest is compounded in the year. So let's say you have a compound interest which compounds the interest 2 times a year bi-yearly, or let's say 4 times a year. So N would be 2 or 4 respectively. So this is the formula that you should remember, and a simple silly mistake to avoid is always remember that these are the formulas when R is in decimal. So if the interest rate is 10%, you take R as 0.1 and not 10. Otherwise, you would get a very, very big number. And also a nice formula to remember is, let us say if you have a question where say one person invested some amount in the bank for 5% rate of interest, 5% rate of simple interest for some amount of time, and another person invested the same amount in another bank on the same rate of interest but compound interest. And if you want to find out what the difference is, obviously the compound interest would be greater, but what exactly the difference in their interest would be, it can be given by 100 upon R whole squared into the difference equals to principal. So if you know the principal and if you know the rate of interest, and this is assuming constant time, you can find D, which is the difference in the interest the compound interest one would get. The more interest, how much more interest would he get? But over here, R is in percentage. So if R is 5%, it is 5 and not 0.05. So just to make this more clear and to avoid silly mistakes, I'll just write it percent. So this is also a nice formula to remember. Now coming to sets. So for sets, there isn't any particular formula that you might want to remember. but there is just a general way of thinking for DLIR when there are questions have which have involved sets. So let's say there is a question that this set of people went to some countries in Europe, this set of people went to some countries in Europe and Asia, etc., etc. So in those type of questions, what you're actually trying to do is you want to make three sets. Let's take the example that we just took right now. Some people visiting countries in America, in Asia, and in Europe. So this is the region that signifies people who went to countries only in Europe. This is the region for only America. This is the region for only Asia. This is A intersection E, so people who went to Asia and Europe, and this similarly for these two regions, and the center region is A intersection E intersection Asia. So whenever you get these type of questions, what you actually want to do is from the hints that are given that five people went only to Asia, 10 people went to Asia and Europe and blah blah blah. You want to form equations on this chart and then you can solve those equations to get other information that is missing. So forming these equations is simple. You just have to imagine uh, this graph as these separate regions, and all these regions add up to the total uh, to the to the total number of people that go over there. So the total would be, let's say if so the total would actually just be A plus B plus C minus A intersection B minus A intersection C minus A intersection D. So you minus this and minus this, but you then minus this center amount three times, so you also add two times A intersection B intersection C. But you don't have to remember all these formulas, you can just make this up intuitively. But this is just a general way of thinking for solving such kind of questions. We'll look at the geometry last, as geometry has a lot of formulas. So if you know the formulas for geometry, this can be the easiest section for you for scoring in quant. But if you don't know the formulas, this might be the worst section because you can't just brute force your answer in geometry, right? You have to know the formula. So let's do this the last. First, let's look at some formulas related to modular arithmetic. Let's move this as well. So for modular arithmetic is questions involving 3 raised to a very insanely huge number like 777. What if we divide this number by, let us say, divide this by 4, and what would be the remainder? So whenever you see such a question, instantly you know that this question is about modular arithmetic. If we are asked 3 raised to 777, what would be the remainder if this was divided by 4? It's asking nothing but what would be the answer of 3 raised to 777 mod 4. So the most important formula for this is you can divide this number, the base over here, which is being raised to an insanely huge amount, by the mod, and then still the mod would apply, it won't go away. So for example, if you had 2 raised to 100 mod 7, so what you could do is you can have 2 raised to 10 raised to 10. So this you can divide this as 2 raised to 10 whole raised to 10, right? And then 2 raised to 10 is nothing but 1024. So then you can find what the remainder would be if you divided 1024 with 7, which would be 2. So it again becomes 2 raised to 10. And then you just keep the mod 7 as is. So 2 raised to 100 mod 7 is exactly equal to 2 raised to 10 mod 7. And again, we know that 2 raised to 10 mod 7 was 2. We just saw that. So the answer would be 2. So this is the most important trick. So not even a formula, but a way how to solve the mod type questions. And for formulas, the formulas are mostly for logs. So if you have questions involving logs, there are some formulas that you should remember. So I'll write all those formulas down quickly and then we'll go through them one by one. So yeah, these are the three important formulas. If you have multiplication inside the log, you could shift this to addition outside the log. If you have division inside, you can shift that subtraction outside. And if you have m raised to n, uh, this n could be taken out over here. So this becomes n times log a of m. So exponentiation becomes multiplication, division becomes subtraction, and multiplication becomes addition. There is also a very important formula for changing the base of a log, which is also very useful for CAT. So let's also look at that. So let us say that if you have a question that says log base a of b, and you want to change the log base, so you to c. So what you could do is you could write this at log base c of b upon log base c of a, or you can also write this as 1 upon log base b of a. So if you want to change these two, you can make this 1 upon, or if you want to change this to a completely new base, like to convert to base 10 to base 2, the formula is this. So log base c of b and log base c of a. So you can use this formula to change the base of the log. Now finally, let's look at some time and distance, speed, time, distance, and work formulas, and then finally let's move on to geometry. So the absolute main formula for speed, time, distance is the basic formula that we learned in school, and that's nothing but distance. Let's call distance d, time t, and speed s for now. So distance equals time into speed. So you can derive everything else using this formula. So this is the main formula that you should know. But some other formulas that you just can keep in mind to make your calculations much faster, because you can't sit on deriving formulas in the exam, right? So to make the calculations much faster, the other formulas that you can remember are, so some of them are related to circular tracks. So let us say if you have a big circular track and then there are two people on this track, A and B, and they are moving either in the same direction or they might be moving in the opposite direction. And the question asks, how many times will they meet? So for that, you can derive those formulas by track length, etc., etc. But a simple way to solve these type of questions is if the uh, let's say if the speeds of these two people, the speed of A is A and the speed of B is B, and they are in the ratio A is to B, and A and B are co-prime. So co-prime means that they only share the factor 1. So if A and B are co-prime and the speeds of these both of the athletes are in the ratio A is to B, and if they are running in opposite directions, they will meet at A plus B different times at A plus B distinct spots. So here, maybe here, maybe here, maybe here. So they will cross their paths at this many different spots, or you can call them this many different times. And if they are running in the same direction, it would be mod of A minus B. So this is a formula that you might want to remember. And another important formula regarding trains that you might want to remember. So this was regarding circular tracks, and another one regarding trains is, let's say there are two trains with a length L1 and L2 and speeds S1 and S2, and they are crossing each other. So the time taken for those trains to cross each other, if they are going in the opposite direction, so opposite direction, it would be L1 plus L2 upon S1 plus S2. And if they are going in the same direction, it would be L2 plus L1. So L1 plus S2, anything. And below you have mod S1 minus S2. So this is also a formula which is particularly helpful if you are facing with problems dealing with trains. So again, all of these could be derived with this basic formula, but Knowing these shortcuts would really help you do it much faster. Let's move this a little below. And again, for questions involving work, where we have questions like Ajay completing this work in this many days, Vimal completing this work in this many days. So let's say if you have two things, Ajay and Vimal, and they both complete the same work in different amount of days. So what you actually always want to do is you want to find their efficiency. So if Ajay finishes the work in 100 days, he completes 1 upon 100th of the work in 1 day. And Vimal, if he completes that work in 37 days, he completes 1 upon 37th of the work in 1 day. So So after you have the efficiencies, you can use the formulas like the number of days they worked times their efficiency. So Ajay's efficiency, Vimal's efficiency should all add up to 100 to be able to complete their work. So that way you'll be able to find out how much days it would take if they worked together. And let's say if you know what the amount days is, let's say Ajay takes X days to finish a work and Vimal takes Y days to finish the work. They both, if they work together every day, they both can finish the work in a X into Y upon X plus Y days. So this is a shortcut formula. You can get to this formula with this equation as well, but it's always good to remember some shortcut formulas. So now let's finally move to geometry. So in geometry, there are a lot of formulas for areas, for parameters, for volumes. So let's start with the very basic of them. So first of all, equation of a line in a geometry is given by y equals to mx plus mx plus c, where m is the slope and c is the y-intercept. So if we have a coordinate like this, if this is the line, so this point is the c, the value of y at this point is the c, and m is nothing but the slope, and slope is just the rise over run. So it would be rise is the difference in the y, so y2 minus y1 for any 2 points on this line upon x2 minus x1. So this would give you the slope. So this is the basic equation for a line. If you have 2 points and you want to find the midpoint, or let us say if we have a line and we are given 2 points on that line and there is a third point which divides the line into the ratio m is to n, to find the coordinates of that point that is dividing this line, the formula is the x coordinate would be mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n. So if this point is the midpoint, so that means the ratio is just 1:1. So that time it becomes x1 plus x2 upon 2 and y1 plus y2 upon 2. But in general, for any ratio, this is the formula you can use to find the coordinates of this point. So if this is A, this is B, and this is P, the coordinates for P would be this. Another good theorem that you might want to know is the tangent secant theorem for a circle. So let's say we have a circle, there is a tangent. So from an external point P, let us say this is the point P, we draw a tangent to the circle to this point T, and we also draw a secant through the same this from the same point P, like this, a secant A and B. So a secant is nothing but a line that touches the circle at exactly 2 points. A tangent is the one that touches it at exactly 1 point. We have a formula that is pt squared is equal to PA into PP. So this PT squared is equal to PA into this PB. So this is also a nice formula to remember. Might not be used for a lot of questions, but if a question arrives which needs this formula, it mostly would be just substitution of the actual values in this formula and you get the answer. Again, some basic formulas. The area regarding triangles, the area of a triangle is, if it is a right angled triangle, it is half times base into height. We also have the Heron's formula for the area of a triangle, which is nothing but root over s times s minus a, s minus b, s minus c, and a, b, c are the sides of the triangle. So a, b, c, these are the sides of the triangles, and s is nothing but a plus b plus c divided by 2. The s is also called the semi-parameter of the triangle, as this is just the half parameter, right? A plus b plus c is the parameter of the triangle, so half parameter. So this is also a formula for finding the area of a triangle if you do know the length, the coordinates. So let's, since we are talking about triangles, one more important formula regarding the triangles is the formula of the radius of the in circle of a triangle. So in circle, so if there is a triangle and this triangle has a circle which touches exactly once each of these things, each of these sides, this is called the incircle of the triangle, and the radius r for this incircle of a triangle is just the area of the triangle upon s, upon the semi-parameter. And if this triangle happens to be a right-angled triangle like this, then there is a shortcut formula of a plus b minus c by 2. So c being the hypotenuse and a and b being the other two sides. So these formulas are for the radius of the incircle. Now another one very good formula to remember is if you are given a random polygon, so any random shape like this, where you have the coordinates of these points like A, B, C, D, E, F, G, and H. If you have these coordinates and you want to find the area of this polygon, you can break this polygon into a lot of random triangles and then find the areas of those triangles and add them up. But there is also a simpler formula, a shortcut method with the formula area equals to half modulus of x1 y2 plus x2 y3 plus dot 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 xn y1 minus y1 x2 plus y2 x3 plus dot 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 yn x1. So using this formula you can easily find the area of any polygon. Now the formulas for cubes and rectangles and spheres, a lot of people already know, so let's not go through that. Actually for sphere, just let's go through the basics of those formulas because some people tend to forget that. So for a sphere, the volume of a sphere is 4 by 3 pi r cube, and the surface area of the sphere is nothing but 4 pi r square. So this is the volume of a sphere, that all the insides, and this is just the surface area, 4 pi r square and 4 by 3 pi r cube. So this is volume, this is the surface area. Now some rare formulas which might not be asked too much, but it is good to know, as if those questions are asked and you know the formula is just putting the values in the formula and getting the answer. So a volume of a cone, so a volume of a cone is 1 by 3 pi r square h. So 1 by 3 pi r square h, and the conical surface area of that CSA of that same cone is just pi r L, where L is nothing but the slant height. So this the height, slanting height of this cone. And if you have a frustum of a cone, so a cone which has been cut off, something like this. So for that, the volume is pi h by 3 into r square plus r, where a small r is the radius of the smaller circle, bigger R is the radius of the bigger circle, and the same CSA for that is pi n into r plus r. So knowing these formulas will be very handy if by chance a question appears regarding frustrums of a cone, then you can easily just use this formula and get the answer. Now just wildcard formulas that are just good to know generally and are good shortcuts if you see problems like those is, if let us say we have p as a prime number and the question is what is p minus 1 factorial mod p. So that is nothing but p minus 1. So if there is a question, for example, there will be the question where the number would be in hundreds. You'll have to find if the number is prime or not. But if we have 6 mod 7, since 7 is prime, we have p minus 1, 6 factorial mod 7. So since 7 is prime and we have the question as 6 minus 1 mod, so p minus 1 mod p, it is nothing but 6. And similarly, we also have p minus 2 factorial mod p equal to 1. So if we had 5 factorial mod 7, that is just 1. So it's okay if you don't know these formulas, but it's a good speed up if you are able to recognize some questions where you can use these shortcut formulas to be able to find the answer much quicker. One more formula regarding parallel lines is, if there are two parallel lines, so two lines which are parallel to each other, the formula, the equations of the lines being ax plus by plus c1 equals to 0 and ax plus by plus c2 equals to 0. The distance between those two lines is just mod c2 minus c1 upon root over a square plus b square. So there are a lot more formulas and you can just keep on going and going and going because the way to get a really good percentile is in CAT cannot be done in a single day. But these are a bunch of good set of formulas which if you review right now, it would increase your chances of scoring good by a lot because these are most of the basic formulas and a lot of the advanced formulas you can derive using these. So it's good if you write those questions, these formulas down in a notebook and then just revise it once or twice before going to exam so that you don't make a silly mistake in a formula. A lot of times, many students, what they do is even though they remember the formula, they remember some of the signs incorrect, and then even though they solve the question very good, they do a simple silly mistake in the formula and they end up getting the wrong answer. A very common of that mistake is in the quadratic formula. A lot of people might forget that this is minus b and not minus a. A lot of students might forget that if you have an equation, let us say that x plus b plus whole square plus y plus c whole squared equals to r square. So this is a general equation of a circle, but for which the radius is r and the center is located at minus b comma minus c and not b comma c. So very small mistakes like this. So it's great if you go through and review these formulas before going to the exam so you can avoid such mistakes. So let's stop over here for today and thanks for watching.